Roger Curtis from Historic Environment Scotland. He's a technical research manager at HES, and he's a chartered building surveyor with extensive experience of traditional buildings. And today he'll be speaking about climate change adaptation. So off you go, Roger.
Hi, thank you. Thank you for the introduction, Karen. And yes, climate change adaptation. As was said, I'm a chartered surveyor with Historic Environment Scotland, normally based at Longmore House in Edinburgh. Obviously, the last year we've not seen much of that, although work has carried on. Quite a few of you may have seen elements of this presentation before. By way of reassurance, I've changed it quite a lot and put in quite a few wider factors, but I'm sure at the end we'll be talking about mortars and wet gables, because pretty much that might be the core of it. So moving along then, why do we need this topic? Why am I talking about it? One of the effects of a changing climate in Scotland is increased rainfall and an alignment of circumstances. So like a lot of building issues, it's often never one thing, it's a combination of factors. So more rain leading to a rising water table in some places. We've got more surface water runoff. We've got a history of poor maintenance, or maybe just a backlog. We've got building elements that may just simply be getting to the end of their life. Some stonework in chimneys, for example. We've also got quite a long history of incorrect and unsuitable materials that might be accelerating decay. I think we've got a poor appreciation of detailing at contractor and practitioner level, and to some degree on the design side as well. And that's leading to some occasionally significant effects, such as leaching of the binder from the wall core and other things. And then operational compliance issues that mean we're having to work in better and generally safer ways. Difficulties of access and working at height mean that people aren't really doing things at higher level that they might otherwise have thought easier of doing. This slide has moved around the presentation for quite a long time, but I've actually put it at the beginning to give you a sort of feeling for thematic scope of where we're going today. We've got a rather bad stylized cottage. This is my drawing, by the way. We've got landslips on the right, so softened earth and movement. We've got trees moving as a result. On the right, we've got water runoff from hills, flash flooding, rising water levels, perhaps nudging on the edge of a cottage or a property. I've also shown the sea, just to indicate that there are pressures from many different directions, and the remains of a building kind of crumbling away there in a sort of stylized fashion. So much of this will be about the building, big focus on gables and the components in that, but also on some of these wider effects. And depending on how the time goes, I will talk briefly about internal conditions and changes to that, but we'll see how we get on. So I'm going to dive straight into the detail, unapologetically, that this is a detail business. The chimney can, tabling, copes, skew copes, tabling, flashings, slater work, parapets, renders and finishes, rainwater goods, solums, ground conditions, comments on hard landscaping, below ground drainage, and footings and sort of building stability issues and considerations. So that's kind of what we're going to canter around. At the end of the presentation, there are links and references to a few HES publications that I hope will be useful and reflect some of our experience. It's by no means all of it, and everyone will have a take on a view, and very pleased to get questions and feedback. Please don't feel you have to memorize this slide, but it's a kind of indicative scribble that shows really where maintenance and climate change, increased rainfall are hitting hard. On the left-hand side, I've overemphasized the defects and how they might be affecting the building, and probably the most significant bits are the ones you won't see, which I'll talk on the next slide. On the right-hand side, a few modest but significant adjustments in scope to building elements and details, ground levels, below ground drainage, air circulation, and condition of the chimney probably are the most important bits. So if you get the top right and the bottom right, you've gone quite a long way to it. We know walls will be an issue, and we can dwell on that later on. So a summary slide that really gives you a feeling for the level of detail that we're going to talk about, and addressing them can yield good results. If you take the previous image as a sort of template of how to get wet or how not to get wet, the internal conditions that this, again, a stylized slideshow, will lead to not only wetting of the mortar and its components inside, but what you might call a leaching out of the binder of the mortar, which in most cases is a lime, possibly clay, with continued dampness and wet. That lime will leach out much as you see stalactites in a cave. The limestone essentially is being mobilized by the water, and then you get loss of mortar. But the technical term is binder migration, and there's an academic paper on it by Heriot-Watt University. Alan Forster was the author a few years ago now, and ultimately you get deflecting masonry and bulges, particularly on gable ends where you have thinner masonry anyway due to flues and press cupboards and things. It doesn't always happen quite so dramatically as I'm showing, but it's a consideration we should be aware of, and there have been a couple of gable end collapses. So this is the sort of slightly harder imperative. What we do about it is perhaps a consideration that is still ongoing, but just hold that thought as to what might be happening inside the wall that you can't see. So what are we looking at? What is the scope of things in, what are the tools in the box for interventions for climate change on traditional and historic buildings? And I think we're in the business of suggesting careful and proportionate details. The scale and the craft is compatible to what is there already, to enhance existing building elements and using an existing palette of materials and techniques. So we're increasing the performance of certain things. So we're talking drip details and that type of provision. I don't think solutions in a tin are our thing. Waterproofing masonry elements is not the whole story, and it's the bits in between that the waterproofers don't cover. Yes, stone does break down and degrade over time under certain conditions, but it's not a wholesale thing, and it's not a factor of time on a single piece of geology. We should also remember about listed building consent, that in fact change is implicit in the listed building consent process. That is why it's there, and I think that most of what I'm going to describe is within the LBC repertoire, and a dialogue with your local authority conservation officer will be the start of some of this. You will need to engage, and possibly if the building is in a conservation area as well. I know there are considerations about pre-application discussions during COVID, and that access is to informal advice is perhaps less than it was. We're also talking about verge details and reinstatement of traditional finishes, because what is coming through reasonably clear is that rubble masonry of a certain quality, it is hard to keep dry, whatever mortar you go for. So I think there's a little bit of a wider rethink needed on that one, and we will be looking at and trialing grouting of wall cores, but I will admit that's not happened to me, or I've not done that just yet, but we've got a couple of projects on the go where we hope to do that work, COVID permitting, in 2021. So starting at the top, this is all pretty noddy to you, but I'm going to emphasize it anyway. the chimney cans and the haunching that holds them in place. I would suggest we're in the hydraulic mortar space for that, or even or an OPC. The cope itself and the overhang and the drip on that chimney, I'd say, is your starting point for an important adaptation. The condition of the masonry on the chimney will be degraded due to salts, due to the damp, due to spalling, and a lot of other factors. And it may be that you are in the business of rebuilding a chimney, particularly if it's not been rebuilt since building. And indeed, it might have had a colliery brick rebuild in the 20s or the 30s, which in itself, in turn, is breaking up. And some of those bricks actually just literally break down over time. You will need to look at the bridges between the flues and the internal conditions within the gable, and then you get slightly into this awkward game of how far down the gable do I go, as a lot of this masonry and mortar will be quite friable. So, but it needs to be addressed, because if it isn't, you will not address the source of much of the damp. And I would suggest that you maintain the ventilation flow through that gable matrix of flues, even if they are closed below. You need that quite thin masonry to be able to dry out, and that needs to happen not only from the outside, hopefully with the right mortar, but also from the inside flue. So keep it open, have a cowl on it. I'm not such a fan of the elephant's feet, as they, I think, restrict perhaps a bit too much, and they're always undersized and they just let the water in anyway. But keep that moving, as ventilation is an important part of indoor air quality and health of the building and the people, as I touched on our previous session. It doesn't need much explanation on what's wrong with this and what's going on here. Heroic attempts to waterproof the entire structure with the gloopy paint that you can see, that is being thrown quite neatly off, and of course the water is coming down the inside anyway. The tell on that is the plant growth. That picture was taken a while ago now. That bud is now a full-size shrub, and you can see the mortar holding the cans has completely breaking away, and indeed settling on the far right. The old stay for the TV aerial is probably doing quite a good job of keeping the whole thing together. So clearly we need something to happen, and the right materials, the right finishes. And if you are going to paint it, use the right paint so that can allow itself to dry out. And I'll touch again on the drying out mechanism. But a plastic-based conventional masonry paint is probably, I'd suggest, not the answer here. Here's a slightly better job done in the land of milk and honey in Edinburgh, of course, but quite nice ashlar repairs to that. And probably the thing to note from an adaptation point of view is that they've put a stainless steel enhanced drip across the top of the parapet, which I think is going to be quite necessary. A lot of Glasgow's architecture, particularly sort of arts and crafts, early 20th century period, is what I call sloped shoulders, parapets and chimney heads and things, which just don't shed water. It's a kind of sloped shoulders thing, as I mentioned before. The skew copes and the tabling. So this is what either side of the chimney now. The ashlar joints to the cope slabs, and the projections and the overhang might be enough, but it might not be enough. And you may be in the business of having to replace this. That's new cut stone and cost, and the rebedding. Do you put the lead underneath or above? There's arguments for both that you'll be familiar with. And the skew putts and the terminations, so where the cope meets the gable, how is that going to be finished? And the decorative skew putt that we know from some architectural styles does, I would suggest, have some sort of function, as well as cuts and channels that may have been missed or lacking, or for very little effort could be put in. This drawing here, or this photograph of a building just south of Edinburgh, shows the situation very well. They've spent a lot of money on rendering with a proprietary render. It's been lined out at some cost. You may want to comment on the style, but it's not really what I'm showing here. the thing that I'm showing here is that for all that work, they did not address any of this. So the skew copes have not been looked at. You can see where the water's come through and the render has spooled off. The chimney itself, they've heroically lined out in imitation of new ashlar, but not addressed the absence of any drip detail at the skew cope. So this is kind of boring but important, as this modern, I think it's a formulated lime of some sort, I couldn't say what, is failing. Just while you're there, noticing the OG gutters now, the joints appear to be leaking in a couple of places, and that's I haven't discovered the simple solution for recaulking such joints, and as a lot of these things are now in their 150th year, maybe more, maybe less. Certainly that's an endemic defect that needs looking at, but we can look at that later on. So just don't focus entirely on the vertical face of the wall. Think about what is on top of the wall. What is the lid? What is the top cover? Otherwise, you'll end up with this situation 3 or 4 years later. I mentioned cuts in skew copes. Here's a nice example from a building in Fife, where the surface water that is running down the cope will actually go into the channel and then into the Rhone below. Likewise, for to prevent water running, nice detail on a building in Fife. This is Curious, where the render that was here is gone, but they were protecting it with this with this channel to route water away from the edge and prevent it running down the face. But masonry work of a certain quality quite often features some sort of lap in the cope, which is obviously something to go for. Quite a lot more work, more cutting, more stone. Not necessarily something that is available to you or your clients, but if you have it, value it and repair it. And if you do need to do a repair or a new stone, copy that, because it is shown to be durable and long lasting, even if, as you can see, the mortar has slightly leached out. On this adaptation here, they've gone for a lead covered cope, but I'm not sure if this gets full marks, as the lead is flush with the render, so you're going to get staining there in the long term. And I talked about round shouldered chimneys, and here is a very good example. So I'm not quite sure in a few years how this will look, as the water is not being thrown off, it's running down the face. And I'd suggest quite a bit of our work is to break up the water's passage down the front, or down the various elevations of the building. So how does a skew cope look with some sort of covering and junction with the slates? This is an example from the Cars scheme in Haddington a few years ago, whereby brand new skew copes, as it happens, they're not lapped, they're just normally butted, but suitably ashlar pointed, and then the half cloaking with the lead, which is quite a common detail and quite a nice way of ensuring that the water drips off the end into the Rhone. In fact, you can see the Rhone takes a return round for a short length onto the gable end as well. So that's perhaps the sort of halfway house we might be looking at. If the stone was in good condition, you might not need to go the whole way around. You could actually just tuck in underneath there, or perhaps cut in on the work. Often this sort of work is hard to achieve on older stone because it might be more broken up and soft, or delaminating and other things. Slating is definitely under some form of review, or certainly checking, and are the current laps correct for the amount of water that we're talking about? If we take the premise that some parts of Scotland are getting 40% more water from the war after 1945, are we configuring our roofs properly? And that's a matter for discussion with your roofer. Maybe the laps are good, but maybe the head laps are good, but the side laps might not be enough. And I've had sort of anecdotal feedback from architects that maybe the side laps are not quite doing what they should be doing. A vapor control layer is now fairly standard. to mitigate airflow or vapor movement, but not to eliminate it. One of the features of a changing climate is overall higher humidity levels, and therefore air movement in roof space is important. And for that reason, I'd suggest under slate felt is a bit too restrictive now. They started using it sort of in the 1930s right up till, well, people still do. I'd probably want a bit more vapor movement within the roof space than that can provide. Cheek nailing, that varies every sixth course or maybe every fourth. I think that's a matter to be taken in the context of the exposure. Remember, the more you cheek nail, the harder it is to do the repairs that a Scotch slate roof or traditionally laid roof allows. But I would suggest there must be a minimum size now when we're redressing or stripping a roof and redressing and relaying or making up the shortfall with some new second-hand material. Each time you redress, the slates get smaller, and if we're going to have head laps and side laps of a credible distance, those slates need to be a decent size, and maybe at the top of the roof you don't want them too small. Just a fairly obvious indicative drawing of a Glasgow a tenement, or indicative Glasgow tenement, with the sarking you know about and the vapor control there, and then the lead detailing as at the junction with the skew cope. Notice no skew putt as such, but an arrangement with the lead to catch any runoff into that. In this presentation, the good drawings are by John Gilbert of John Gilbert Architects, and the more clunky ones are all my own work. Another slate detail that quite often gets missed on verges is little cuts, which is a nice feature to again keep as much water off the face of the gable as you can. That keeps it clean and keeps the render or the covering or the paint under as minimal stress as possible. And I've certainly seen several buildings in the last few years where the verge has been reslated to extend proud by about an inch or an inch and a half beyond the plane of the gable end, which I'd suggest is a good basic measure to address increased precipitation. Rainwater goods. Often in climate change discussions, people say, oh, well, you just need bigger rains and downpipes and it's job done. I wouldn't want to suggest that traditional and historic buildings have to go for a mass uplift in capacity necessarily, but certainly a cognizance that there is greater vulnerability to blockages. If you have a higher water flow, you'll move debris, seagulls' feathers, tennis balls and beer cans or whatever else is up there quicker into the choke points, and then they will overflow with more intensity. So wider roans may be a part of managing that, but actually what's also happened is people have reduced the size of roans and downpipes over time, and there's quite an extreme example that I'll show you in the next slide or two. So really it's not necessarily what was originally configured in the building, it's what's happened to the building subsequently with suboptimal repairs or poor modifications or additions and things that I'll show you. Here is I think it's a 2.5 inch roan here that's clearly not managing the fall. So the rate at which the water drains from one to the other is not very steep in this example, and therefore there are considerations of ponding in the roan and overtopping, which you can see is happening. And it may be that an extra ½ inch would be useful here, but that will mean new roan hooks, which means removal of slate on the east course and quite a lot of work. So just make sure that it's the route and the configuration that needs upgrading, not necessarily the actual roan itself. So look at the swan necks and the downpipe side first before tackling any potential enlargement. This is a large building in southwest Scotland at Galston, and if you look at the right hand part of the picture, nearly all of the cast rainwater goods drain through this, come down off a sequence of roof pitches down into this single point here, and the drop from the inside of that OG there was reduced to a domestic size wash hand basin, 1.5 inch bore, in a retrofit program that was not that long ago, and that has caused extensive problems. You can get a sniff of that by the efflorescence around these various hoppers, and it was a shame that really wasn't picked up, the capacity of it. So in that one, you can see above the bottom hopper, that was the original size. This one within the wall, which you can't see, was reduced as part of the upgrade work. Now, there were other issues with water ingress on the gable ends. Again, you can see efflorescence there too, which I'll come on to, but one of the main causes here in this issue was the capacity of where the water was being asked to go. I talked about alterations and additions not always being configured quite as they could be, and here is a mid-19th century building with an early 20th century porch with the characteristic zinc roof, which hasn't really been well integrated with the water coming off from higher up, and you can see all sorts of things clearly going wrong. I often get asked about algal growth on buildings and how do they remove green, and what special biocides do we need? And my general approach is if that elevation is kept dry with proper drainage, you tend not to get quite so much green. This is generally a feature of an easterly or a northeasterly elevation, because it doesn't get enough drying wind and heat to take the stone into a slightly drier space, and hence you get a bit more green. So generally my advice with this is, if you get the water drainage and disposal right, you should not have too much of the green at all. Walls then, and I deliberately put this kind of not low down the list, but midway through, because again, as I touched on, it is probably not the biggest cause in itself, although there's plenty going on there too. So craggy rubble and recess pointing has a very high surface area, to say nothing of the shelving and ponding on the tops of the masonry units. If you have a very high surface area, you've got a higher area of potential failure. If that is cement, you have a water retention behind it issue. Depending on the lime, you might have a hydraulic with a tendency to shrink. You might have a more traditional mortar that might not have carbonated as well as it could have done, and lots of other reasons. But in fact, we should view the mortar on a wall as a mechanism for vapor and water exchange rather than a total barrier. And your pointing and finish style should really be seeking to maximize vapor dispersal, so pulling moisture out of that wall all the time. And technical paper 32 by David Wiggins talks about this movement of water vapor and the importance of taking it out. And generally, a recess point reduces that evaporative surface to a degree. Obviously, if it's a sandstone, it'll be doing a bit of that work by the nature of that stone. But if it's a granite, the mortar will be the only mechanism really out of vapor out of the building. And this brings me to my sort of general point, which is not applicable everywhere, but is certainly perhaps a factor, is that we know generally that most rubble buildings, certainly in many parts of Scotland, were rendered or covered with some form of coating, and maybe we need to consider reinstatement of such finishes if some of the climate change impacts are to be addressed. So, sort of work in progress. I've got a PhD student on the case, gathering evidence, both in terms of what history has shown, and that's TP31 link at the end of the presentation, and indeed what we need to do about it, both in terms of protecting the stonework and keeping that stone going with a surface that we can recognize and be appreciative of for as long as possible, and let the mortar and the covering for that, generally lime wash, take the hit of what we know is increased attrition, certainly from the water. If the numbers for climate change don't necessarily show an increase in wind-driven rain as such, but certainly a lot more rain, some of which is wind-driven. So straight into the walls piece, as we indicate. We've had an opportunity of trialing this in a couple of cases, and the Sandhar refurbishment case study, the link is at the end of the presentation, might give you an idea of where I think we should be going with this. And also, let's consider external wall insulation opportunities for neglected gables. And you and I know we can drive around Glasgow and see plenty which are just crying out for attention, and maybe an external wall insulation option in combination with a traditional finish of some sort might be the way ahead. Just slightly an indicative drawing that I did a long time ago now, but I think it's still kind of relevant, just showing the liquid and the vapor exchange mechanisms. And the idea is that this wet front, and a sort of hypothetical dotted line shown here, never gets in here. If it gets here, you've got probably some quite significant issues. And it's interesting looking at a number of gables, even that are not perfect by any means. You very rarely get to total saturation inside unless you have some quite sort of meaty defects. So just a very simplified drawing. But what I'm perhaps coming to is that we need perhaps a better way of traditionally finishing this, or indeed reinstating what people did traditionally. I appreciate this big aesthetic and other considerations in that, but there is an argument that suggests the imperative might demand that answer. And to some extent, even where buildings might have been finished in more than one way, this is a close-up of a building in Stirling. On the right, you've got a coursed ashlar, or sort of ashlar with a very hard windstone type material on the right, and then the gable end, the subordinate elevation, was smaller rubble units with a protective render. The last fragments you can still see here. And then interestingly, for this architectural style, the render did go over some of the coins and feathered into the edge there. So a combination of the formal masonry on the right and a less expensive, cheaper rubble, but protected and finished with the coating that you can see the last traces of. And also a long tradition of masonry detailing in Scotland, of string courses and other embellishments on elevations, some of which entirely decorative, but actually some of which had a practical function. So in the Gothic idiom, the hood moulding over a window is a very good way of managing water. And likewise, string courses, which we see in many 16th and 17th century buildings in various stylized forms, also allow water to be shed off the elevation at various stages. And again, a clunky drawing here, but on the right, on the left-hand side, we've got that sort of shedding of water sequence that at each point, various building elements are losing water, specifically projecting sills and string courses. And we know that there are plenty of examples in Scotland of domestic architecture where the windowsill doesn't project. And if that's in a tenement scenario, quite often the lower two floors of the tenement quite often have accelerated damage to the stone just beneath the window at a point where the masonry is the narrowest, and it's no surprise that you'll find defects there. We've got a couple of leaky gables of our own. This is the building that was repointed not that long ago, possibly 6 years ago or so. And the last couple of winters, this has started to to show water ingress. No surprise that the drops are coming out of the window head there on the inside lining, which is probably an indication that this triangle, not terribly big, this is not a big building, has become progressively saturated. There might be a modest amount coming here. This is not a southwest gable. This actually faces to the east. So there are considerations of changes in prevailing wind and weather direction. And we're getting a weather station put up here so we can start getting a feel for our areas that were previously less vulnerable due to reduced exposure to prevailing winds, and now perhaps getting more. I think the point from this image is when this building was originally conceived a long time ago, this type of masonry finish was probably not in the playbook, and the illustrations and the archaeological evidence support that. So maybe some form of flush covering, lime roche or render or something is maybe needed here. Notice also that the Q-scope detailing is very tight to the rest of the masonry. There's no shedding function going on there at all. So we are potentially into an alteration scenario with the consents and things I touched on. Just to give an example, this is a building in Dunbar with the remains of historic render and lime wash. It's just surviving here. You can't, the light doesn't show it well, but it's kind of there. And then the exposed elevation facing southwest has lost everything. The stone has suffered quite considerably. As part of a reconstruction process with a local charity, we reinstated much of this building. We are now in this situation with the flush point of the lime wash. Interesting that the lime wash, the best lime wash, was done with seawater that gave a very tight finish. No white on your hands when you rub that one. So an observation really about reinstatement of renders. Obviously a significant visual difference in terms of ye olde lumpy Walt Disney cartoony stone that this is showing with what that is and what the evidence was suggesting. I touched on windows and sort of basic measures for this. This was put in a B-listed church in the Scottish borders as part of a volunteer working party, and has proved very successful in keeping this lower section of the wall, which faced southwest, keeping that significantly drier than it was before, just by the act of throwing the water off. So it had less contact. So the runoff from the window that came straight down has been thrown clear. Sort of small, but significant. And there's a long history of this on the continent of Europe. This is a building in Stockholm, where a long tradition of copper has been used. And here you can see they've augmented some of the string horses and window sill details on this mid-19th century sort of decorative tower. You also see it in Germany a lot. So clearly they've picked up on this modification detail, and quite significant. But the way it's done, as I touched on, with appropriate levels of craft and detailing, I would say that is entirely in keeping with the sort of overall ethos of the building, and the fact that you need to keep it dry. That's possibly the first function of any structure. Sandhar in Shetland is a 1780s laird's house, which had a cement flush point dating probably just after the war. This gable faced the west-northwest, and was very damp and very wet, with water dripping over the window heads in various rooms, and part of it was effectively unusable. We supported a local architect's practice in addressing this area, removal of most of the cement, flush point with a traditional mortar, a thin hand cast tile, and then 2 or 3 coats of lime wash over pretty much anything that moved, including all the dressings and the details, which I would suggest in a mistaken understanding of a weather pattern increasingly have been left uncovered in work. The main difference here was the chimney head itself and the chimney cope, which is quite sticky outy, quite an aggressive line there, which has got very little resemblance to the 1780 version, but we felt that was necessary to shed the water from the chimney cope itself and keep dry from the top. That needed listed building consent, which was achieved in the normal way, and that building that is now, gosh, six years old now, and they've been dry every winter since. So a significant improvement in habitability and building condition. Just so you know, you can see that's the original sort of, well, the 1940s, 50s era finish that was removed. And other options for addressing masonry are clearly available. This is a 1930s building where the weatherboarding was made a kind of nearly vernacular feature of it. So I'm not saying we stick weatherboards everywhere, but it's an option in certain circumstances, or indeed in design for new builds. I couldn't tell if that was done as part of the original work or as part of the design. I think the fact that the chimney is proud suggests that they were planning on butting up. And also bio coatings of some sort. It's an extreme example here, but it will have some attritional function as well as encouraging a little microclimate and ecological niches for everything. Of course, none of this is maintenance free. You can see they've been carefully cutting away from the parapet here, and they're not being quite so diligent here. So this is just a way of thinking as opposed to necessarily a specific example, but I just chuck that in there. I'm conscious of time now, so I need to rattle on. We don't like talking about drains, but I think it's really important. I've mentioned rising water levels. We get a lot of inquiries at HES by homeowners with damp issues of all types. And one of our earlier questions is, what is the drainage around the building? When was it last cleaned out? Where does the pipe go? And generally, if people can't answer those, I don't know when it was cleaned and I have no idea where the pipe goes, it probably means it's been blocked for some time. So the solum or the areas adjacent will be pretty wet. And then, of course, we are straight into dry rot territory. You know about restrictions on combined drainage. So we might need to be reconfiguring external drainage anyway as part of updates and repair programs. And the other thing to think about is other people's water and the effect of that coming off from roads or culverts, or the neighbours blocked something. And the consequence is that over and above the conditions for dry rot or timber decay, but softening of the footing, so the ground becoming more plastic and settling, which leads to cracks and things. And you'll see this quite a bit on corners. Here's my ugly drain photograph. That doesn't need much explanation. And here is a corner where the leaching or settlement has gradually led to the cracking. You see a little bit of repair has been done there in the past, but you can see how damp this is, just the conditions. So you know the water around the building is important in how you manage it to prevent this. This is a clay cord wall, and I suspect the situation has not been helped by the very hard 1950s pointing that's not letting that dry out particularly much. You'll be aware of different ways of handling below ground water. That arrangement, I would suggest, is quite hard to access and quite hard to clean. This has to be an easier way in to address regular maintenance. Ground levels, I think, are all part of the mix, and we need to, if we're going to get more water, we need to address as many as the areas that we can address very firmly, so that the ones we can't are slightly mitigated. So this wall, for example, may have a cement render on it, and maybe the client can't afford to take it off, and maybe it's in good condition and doesn't need to come off. Therefore, this ground level needs to be nice and low. This air vent needs to be working properly. This solum needs to be properly ventilated, so that we don't get a progressive build-up invariably in the lower part of the wall, with the consequent effects on the floor joists. I would hold that if you keep all this moving and happy, you shouldn't get decay here. But if this does go wrong, particularly with hard landscaping here that prevents the soil around losing a good amount of vapor, you will reach the critical levels of saturation, and then you get the decay kicking in. Here's an example. We did this with the National Trust at a cottage near Cooper. We went a bit mad on the gravel, as you can see, but the principle still stands, and you can see the original ground level, which had slabs hard up against this. Definitely not a good idea. Please keep this gravel as fine as you can, right down to sand, as that has the greatest capillary draw out of the soil. Big pebbles the size of cricket balls won't really allow much vapor to be shifted and dispersed. And just drawing to a close now, that the sort of wider area things about water coming off from elsewhere, you can do all you can to the building. You can get the drips right, the render right, the mortar, everything under the floors sorted as I've indicated. But if you get a load of water in from somewhere else, that's kind of all for nothing. So spend effort on banks behind houses, on stopping water coming off the road or intercepting it before it gets to your building. Because certainly the intensity of rainfall is increasing, and we're getting a lot of water, flash flooding, if that's almost the right word. So it's not a river rising up to flood you, it's water running off a hill or a close or an industrial estate around you that's just bottling down, finding their way out, that might well pass your client's back door. And this is a situation that we really don't want. We spend all the time and effort trying to get the building fabric right, yet actually, if your immediate environment is regularly getting soused, that counts for nothing. And this really is an advertisement for Mini Digger and scraping back that accumulated gravel around the front of the house so the gradient takes it away in the opposite direction to this pond that's at the front of the house. And again, the color, the vegetation is all telling you that this has been wet for perhaps longer than it should have been. Promise you we're nearly there now. So critical infrastructure vulnerabilities. This is not a big drain that takes a burn underneath the high street of the town of Jedburgh in southern Scotland. In some recent heavy weather a few years ago, debris from timber operations further up blocked this, and in a matter of hours, the high street of Jedburgh was a river, causing hundreds of thousands of pounds of flooding to shops all down the high street, all because everything had become concentrated in this point of critical vulnerability. So just try and look beyond the building if you can, and make some sort of assessment about what might be coming your way if someone else doesn't entirely control things as they could. I think we don't really have time for internal, but if we're going to get a damper environment, the relative humidity inside is going to be higher, the effects of things will be exaggerated. And that means generally insects and pests have a better time, and maybe some objects and contents are going to start to degrade in a different way than before. If I can just say ventilation, 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 and a little bit of background heat can go a long way to addressing this if your masonry fabric is reasonably well functioning. These are the two technical papers that I referred to. So this is the examples of historic renders surviving, giving us an indication of finish and how that finish would appear to be working. This illustration shows Kissenwell Castle. Probably some of this render is dating from the 1650s, 1680s, maybe, perhaps the 1720s. And then on the right here, you have the microstructure, which talks about drying out of walls and surface areas and vapor and all that stuff that I touched on. These are fairly new, but came out last year, so perhaps get a look at those. And then a few links to things, the Sandhar case study and the short guide 11. So this is really perhaps the meat of the talk, and you'll recognize a lot of the pictures and examples that I've given in this presentation. So that's the That's Climate Change Adaptation, short guide 11. It's not terribly short, but there we are. And then maybe for your clients or just a bit of introduction, a shorter 10-page document on damp gables, which perhaps sort of is a quicker route to some of these issues, but more simpler explanations really for homeowners. So I think I probably better stop, and very happy to take questions if you guys have time.
Thanks, Roger. Start my video again, hang on. That was great, really interesting, thanks. There is a couple of questions which I read out in a second. Just to remind everybody, we put up a recording of this session on our website. Give us a couple of days, should be there next week, so you can then see all the links and all the content again. And I read out questions. First question from Sarah. Any advice for the best method of maintaining airflow existing air vents if extending out from a traditional building?
Right, so you're doing an extension and there's an air vent there, which, you know, spookily enough is in the wrong place. I think you could probably do some sort of cheap and cheerful arrangement, maybe with some form of drain pipe that just allows the air to keep moving underneath. Quite often you have more than one on an elevation. So a cottage might have two either side of the front door, maybe two at the back. And in truth, if you lost one, maybe the others would be enough. But I think I would be looking at just routing something underneath your extension that just comes out just beyond the return, and then keeps that going. That could be a plastic drain pipe or ceramic. You don't get square ones to match the opening of the original though, but that doesn't matter. That's a matter of aesthetics, not performance.
Okay, next question from Tibor. Have you had any experience in implementing below ground clay heavy soil barriers around buildings?
No and yes. I've had a little bit of experience of using the clay bentonite roll as a way of externally tanking, as it were, where you had a retaining wall and you had no other way of holding water back. You couldn't reduce the level because, you know, whatever reasons. Is that the angle of the question? I mean, essentially one dug out a channel behind the building, put the sheet in, backfilled as a way of mitigating the liquid water ingress.
Okay. Thank you. Another question from Esther this time. Did the metal flushing to the parapet require listed building consent? In
Edinburgh.
Yes.
That building was an unlisted tenement. So in fact, they didn't have to worry. It was a conservation area though. So you could say that's just on the edge.
So best to maybe check with the authorities, it would maybe be the advice, or?
Yeah, I think it's one of those, you ring them up and say, look, I'm planning on doing this. Will this need consent? And then they'll give you a slightly sort of oblique reply and say you've got to pay the fee and all that sort of misery. But I think you'd have to ask the question. Yes.
Okay, thank you. And one last question from Andrea. Advice on wind-driven horizontal rain on a traditional ashlar facade. How to mitigate the problem of water ingress?
It depends on the quality of the ashlar work. Generally, ashlar is, by its nature, is quite good quality stone. Otherwise, you can't cut it like that. The joints are very fine. I'd be suggesting to have water ingress on an ashlar elevation through wind-driven rain is unusual. And generally, I'd be looking higher up. I'd be saying, is there a parapet gutter there that's not working? Have I got overtopping? Have I got some sort of blockage? Have I got something else? Of all the sort of building styles that are resilient, good ashlar work with 2mm joints is probably quite hard to have wind-driven rain causing you that level of problem. Of course, the stone will absorb a bit and the joints will absorb it. Of course they will. But not normally enough to cause saturation. So I might be looking elsewhere for the source of the trouble. That's only half an answer, I appreciate it.
Building is on the western coast facing the Clyde is the additional information to this, but I'm not sure if that
Tough
could
gig.
be the only cause.
Absolutely tough gig. And this is no doubt why a lot of the sort of Greenock and, you know, Dunoon and all that sort of area, there's a lot of ashlar work that's been painted. And you might be in a lime washing situation. There are mineral paint options. I'm not such a fan of mineral paint as some are. It's not as breathable as they say. Everything's breathable to a point, but is it breathable enough? But I kind of know where the question's going, but I probably wouldn't be reaching for the silicon material. I'd be perhaps looking around for other options. I think detailing is everything. Wind-driven rain is a factor, but we know also the wind doesn't blow the rain and the wind all the time. So quite a lot of the precipitation is downwards too, is straight downwards.
Okay.
But I need numbers on that before I go further.
And just one last question, if that's okay. Any advice on keeping cupboard recesses dry where the sandstone rubble walls are much thinner?
Yeah, no, absolutely on the money. This is the gable end question where you've got the flues and the press cupboards, and maybe the gap between the back of your cupboard and the outside wall could be maybe 200 mil, maybe even less, and that has suffered and degraded mortar. There is also a temperature factor there, so you'll get condensation there, not necessarily because it's wet, but because it's a whole lot colder than the rest of the room, particularly with the door shut and loads of books in there or something. I would suggest that's an outdoor treatment consideration, and I think we're back to the option for a render, a little bit like that house I showed you in Stirling, where you had the very craggy windstone, not absorbing any water at all, mortar joints doing all the work, and they're open and craggy, giving a big target for water. It might be that the upgrade is looking at new renders outside. Certainly as mitigation for press cupboard mold or condensation, you can put wood fiber in the back of that as a way of reducing the sort of thermal transmittance, and that might help. The danger is you sort of patch up a kind of wetness issue on the other side. But as with all these things, it sometimes needs a little bit of everything, or a little bit of something here and a bit of something there, and gradually you get towards an answer that is affordable and achievable. Because the perfect world and the perfect solution, very, very few people can say, yes, I'll pay you to do that, I want that, and I want that. It's always a bit less perfect than that.
Thank you, Roger. That was super interesting. Lots of knowledge there. Thanks again.
Great. Well, you know where we live. We do take email inquiries, and very happy to have dialogues with architects on these matters, because it affects us all, and we need to sort it out. And each day is a school day.
True. Just to let you know, Roger will be joining us once again for the last part of this kind of mini series on the 5th of May, and the topic is traditional mortars. And that's all.
There will be an element of repetition and duplication here, because wet gables is tied up with mortars and things. So I won't apologise if some of these sort of pictures and comments get rehearsed a wee bit. I'm afraid that's just the nature of it. But plenty to say and to dig into a bit of detail on the mortars and renders. Yeah, great.
Yeah, perfect.
Okay, thank you.
Looking forward to it. Bye, everybody.
Thank you.
Bye.
Bye.